Let's first fix these two things, and then we'll take a look at what? Security. And that's where DMVPN comes in. Dynamic multi-point VPN. What is this? The way it works, the way dynamic multi-point VPN or DMVPN works is in the same topology, you define and designate at least one of the devices as what is known as the next hop server or NHS. All right. I'll designate, let's say R1, the headquarter site, as the NHS. The way it works, once I designate R1 as the NHS, I will go to all my spokes or clients, and I'll tell them, all of them, I'll do the same config on all of the devices. I'm going to tell them using the IP NHS command, my next hop server is, IP NHRP NHS. My next hop server is 192.168.1.1. How do I reach it? Because this is a tunnel IP. I need to create a map for it. 192.168.1.1 is reachable via this public address. This guy does need to have a static public IP. Got it? So when I configure it with these two parameters on these clients, as soon as their interface pops in or comes up, it will go and register itself with the NHS. What do I mean by register itself? In that registration, it will tell the NHS, listen, my tunnel IP is 192.168.1.2. I've been assigned this IP address from my ISP, let's say 151.1.7.1. This table is now maintained where? On the NHS. This is called a registration. So as soon as R2 comes up, the interface comes up, it will go and register based on this configuration to the NHS. 3 will do the same thing. Whatever its address is, 175.111. 4 will do the same thing. 99.111. And let's say 5 does the same thing. Now, who has all the mappings? The NHS has all the mappings. This part is taken care of. So I'm going to take this out, clean it up, but I'll keep the mapping table that has been created dynamically on the NHS, this table over here. Let's say I'm sitting on R2. How many maps do I have on R2? I just have one map. The map to my NHS. Somebody comes over here and says ping 192.168.1.4. Do I have a map for 1.4? No, but I do have a reachability saying that this is my NHS. So I not only use the NHS for the registration up front, I will also use the NHS for resolution. I'm going to send a request to him saying what? Listen, I need to get to 192.168.1.4. Do you happen to know the public address for it? Says, yes, I do. What is it? Although it was dynamic, but I know it. He sends him a response saying 192.168.1.4 is, what was it, 99.111. Says, thank you very much, proceeds, and sends the, not 5, sorry, sends that to this guy, direct. So I went over here just to do the resolution. Like DNS, if I want to go to google.com or facebook.com, my first packet is not going to google.com or facebook.com, it's going to my DNS server, which resolves the IP address. The only difference over here in the resolution is I'm resolving a public IP to a private IP, whereas DNS resolves a public IP to its domain name. Understood, guys? Everybody okay with this? You understand the role of the NHS over here. Now, the good thing about this is if I go over there and create this resolution for the next 2 hours, I will keep this dynamic registration. So I don't need to worry about going back to my NHS over and over again. I just do it once, do the resolution, cache the information in my NHRP table. And in the NHRP table, you will see that. You'll see this as a static entry, and you'll see this entry as a dynamic entry. So you will see, for example, on R2, an entry for 1.4 is 99.111 based on these dynamic IPs as a dynamic entry over here on R2. So for the next 2 hours, by default, that's the timer. I will use the same entry to go out. You all good with this? Now this is dynamic. This gives you that scalability because a new site comes up. I don't need to do too much of the configuration. Let's take a look at the configuration that I need to do. So how do I do DMVPN now? I showed you the MGRE. I'll just copy the same config over here and we'll modify it because the only thing that we've done is the tunnel interface. So on R1, the first thing that I will do is I'll say no interface tunnel 1. What does that do? Gets rid of all this old config. So what do I need to do on this guy? I'm going to make R1 into my next hop server. Get rid of the old tunnel, IP address, tunnel source, tunnel mode, tunnel NHRP network ID 1. That's it. By turning on NHRP on that interface, every router by default is capable of being an NHS. So all I got to do is turn on NHRP on it. It automatically has the capability of receiving a dynamic registration and doing the resolution. So every router is NHS capable by default. You don't need to do anything special to make it capable. Understood? So let's do that on R1. Get rid of the old tunnel and put the new configuration on it. So the old tunnel is gone. So it just got the new tunnel up. Now, how many mappings do I have on the NHS right now? None. Blank. Why? Nobody's registered right now. I haven't configured the other devices to register to him as the NHS. I do have my new network up, which is the 192.168. I do have it as a MGRE interface. My NHRP table right now is blank. Because I'm the NHS, I'm hoping that the clients will come in and register. So I'm going to do that over on router 2. Router 2, NHS or NH clients, next hop clients. Again, I'm going to get rid of the interface, the old config. Put the new config in, does have the source, the IP address, the source, MGRE, enable NHRP. Now my mapping. IP, NHRP, NHS. My NHS is 1.1, and the way I reach it is using 192.1.10.1. That's the only mapping that I need to do. I need to point to my NHS. My NHS is 192.168.1.1, and the way I reach it is via this public address of 192.1.10.1. By putting this command in, IP, NHRP, NHS, I'm telling it to register. Absolutely. It's not primary and secondary. They're in like an active state. So I'm going to register to both if I have two NHS. We'll do that lab as well. I'll show you if you have two, how do you set the two up in a redundant manner. Otherwise, if you have a single NHS, you have a single point of failure, right? We'll do that. I'll show you how to do that. Very simple though. You guys are okay with this, right? Any questions? Let's do this and see the effect of it. So I'm getting rid of the old tunnel network that I use for MGRE and now implementing the new tunnel. So router 2, done. IP, NHRP, I have one mapping for my NHS, all right? And if I do a show interface tunnel, one tunnel. Now, if I go to router 1, remember this command yielded no output because I did not have any mapping. As soon as R2 came in, it automatically registered to me because of the IP, NHRP, NHS command. And there you go. You have a mapping now. I know how to go to 2. It's a dynamic mapping. And this is the public address for 2. So whatever the address is of that R2 device, it will go and register with me. Whether it's dynamic, static, doesn't matter. If it changes, it'll tell me what the change is. So it updates me and I override the old registration. Good so far? So I don't need to map the other guys. How about the config on R3? What do I need to do for R3? Or actually for all of them now. So R3, what do I do? R2 I done, R3. Change the IP over here. How about the rest? Exactly the same. And this gives you that, what? That level of scalability, because every new site that comes up, this is the entire config that you need to do. Not entire, but this is the config that I need to do. I don't need to worry about mapping multiple different devices. So if I go to router 3 now and paste it, my tunnel should come up. On R1 now, I'll have a new map. So I have a map for 2 and I have a map for 3. The registration is done. How about 4? Almost the same config. Just change the IP. The rest is the same. Again, as I'm doing this, more and more devices are now getting registered. I had a 2, a 3, and a 4 register already. Yeah. And the last one. Five. The rest is the same. All I'm changing is the IP. Good so far, guys? And how many mappings do I have on the clients? By default, just one. And that one mapping is static towards the NHS, correct. Except for R1, which has all the mappings. 2, 3, 4, and 5. At this point, no. If you wanted to, you could do IP NHRP authentication, which is the NHRP authentication mechanism. Might be under the other interface. Show tunnel 1, IP NHRP. authentication, and put a password. I don't do that generally. Why not? Because this is still clear text. My authentication, the way I'm going to do it remote, is through IPsec. So I'm not only authenticating my device, I'm also encrypting it. So rather than doing authentication at the NHRP level, I do it at the IPsec level. But you could do it at the NHRP level as well. All right. Everybody okay with this? Now, let's take a look at the flow now. I'm sitting over here. I want to go to 5, 2 to 5. Let's check. Show IP route. If I ping 192.168.1.5, which entry does it match in the routing table? This one. So based on the routing table, it will create the outgoing address as well. So 192.168.1.5 is the destination. Source is going to be the outgoing interface, which is 1.2 actually, sorry. Now it sees it's a tunnel. So if it sees it's a tunnel, what does it do? Let me check the tunnel characteristics. What type of tunnel is it? I don't know that yet. So it checks the tunnel, and what does it find over there? A couple of very important things. Number one, it says it's a tunnel. So I need to do what? Encapsulation. So the first thing it'll do is it'll put the outer header. I need to do encapsulation. And my source address is 20.2 on the outside header. Now I need to figure out the destination over here. Sees, oh, it's MGRE. So now it needs to figure out what? 192.168.1.5 in where? In my NHRP table. You guys agree? Will it find anything over there? It'll find my NHS, but it doesn't find what? 192.168.1.5. So because it has been configured with the NHS, what does it do? It'll send a resolution request to whom? To NHS, saying who is 192.168.1.5, and the response comes back saying what? 50.5. It puts into the local NHRP table and forwards a packet. And by doing that, you would have the communication. So once I have that resolution done, I will take that resolution, put it into this packet. But at the same time, now this guy will have a new mapping dynamically created to 50.5. And this mapping will stay there for 2 hours. All right. 7,200 seconds, basically. Let's check it. Let's see if it works. What I'm going to do is I'm not going to do a ping. I want to do a trace route so I can show you that the first packet actually traverses from where to where? From the client to the NHS first. So trace route to 192.168.1.5. I'm trying to go to 1.5. Source, I don't care because it's going to use a tunnel anyways. But I'm going to do this probe 1 numeric. That way I don't have those... what do you call it? I'm just going to send one probe packet so it doesn't do that timeout type of thing. Notice where did it go first? 1, and then it went to 5. Why did it go to 1? It went to 1 to do the resolution, but now it's done the resolution. And in your NHRP table, you will see 192.168.1.5, and it'll expire in 1 hour, 59 minutes, 45 seconds. And this is the map. Now that I have this, which was created dynamically, by the way, now it will go direct. If I do another trace route, it will not have 2 hops. It will have a single hop. Understood, guys? Again, the Ceph table, you can see that. If you want to check it, you can do this. It is just because it's directly connected, it'll be tunnel 1. Let me see if I can show. Interesting traffic, IPsec and all that. I haven't gotten to that. I'll get to that. Still setting up the directly connected networks. NHS public IP should be static. Correct, Faisal. Now I've gone where I need every device to have a static public IP to where just the NHS needs to have a static public IP. But you're right. It needs to have a static public IP because I'm pointing to it. Good so far, guys? And same thing, if I did this towards 1.4, the first packet, Pro 1 numeric, it is a quick way of doing the trace route. 1 and 4, if I do it again, direct. Do you understand that? So the first packet is going there for the resolution and then direct packets. The other thing that is very important to understand over here, the reason I am doing that is because this is a directly connected network, right? The directly connected network says I need to go directly to it. So that's why it goes and sends a packet like that. If it's learned through something else, it'll take a look at the next stop. Give me a minute, you'll see that as well. Everybody okay with that? So at this point on my tunnel network, communication, although my mapping is only visible on where? The NHS. On this tunnel network, if I want to go from point A to point B, am I going hub and spoke or I'm going direct? Am I going hub and spoke or I'm going direct on this NHS network? If I want to go anywhere on the 192.168.1 network. Nope, I'm going direct. Hub and spoke is just a resolution if you think about it. My data traffic is direct. It's like saying when I go to the internet, I'm going to DNS first, right? So that you wouldn't consider. Going to DNS would not be considered to be hub and spoke. Otherwise, if you look at it, every communication that happens to the internet is hub and spoke because your hub being your DNS server. You get my point, Rahmatullah? So your data traffic is the one that decides whether you're doing hub and spoke or not. And in that case, it is what? Direct, spoke to spoke, or client to client, direct communication. But something that Mazen brought up was very important is that I've just established at this point the communication between these devices where? On this directly connected network. My responsibility, my actual objective is not to connect 5 routers to each other. My objective is to connect the LAN segments behind them to each other. Right? So I need to run routing. Now, when I run routing, most of the routing protocols that I'm going to be running are going to be running what? Multicasting. Yeah? When I set this up as my NHS, this is an NHS by default only for unicast traffic. It is not the NHS for any multicast traffic. When I want to send an EIGRP update from or establish an EIGRP neighbor relationship, what does my EIGRP or OSPF packet look like? Source, I'm on the tunnel. So it's going to be 192.168.1.x. Let's take EIGRP as an example, 224.0.0.10. So what's the destination IP over here? It's multicast. Yeah. So NHS will not help me over there because the NHS is only an NHS for what? Unicast traffic. So if I want my router 2 to establish a EIGRP or any routing protocol neighbor relationship, I need to tell it where to send the multicast traffic to. It would not be feasible to send an established neighbor relationship with the other routers because I don't know their IP addresses over here. I would need to do a manual map for my multicast traffic. So for that reason, what generally happens is you would set up your NHS as your routing hub. So all your control plane traffic, you're going to forward it to whom? You're going to set up a relationship, a routing protocol relationship with the NHS. And the NHS then is responsible to forward that control plane traffic towards the other clients. So my EIGRP or OSPF neighbor relationship will only form with whom? NHS, because that's the only one that has a static public IP. For routing protocols to work, I need to do a manual map. And it's not feasible to do a manual map with the other clients that might have dynamic IPs. So how do I do that? What do I need to do to accomplish routing protocols over here? Because my main objective is to connect these different devices to each other. On the clients, let's start the clients first. On the clients, I'll say IP, NHRP, map, the keyword multicast. If a packet comes in with a multicast destination address, send it to 10.1. So what I'm saying is when EIGRP sends a packet, internal packet would look like this. I need to send it through the 192.168.1.0 tunnel network. It goes to the tunnel, says, okay, this is my destination address. It's over the tunnel. So the tunnel source is 20.2. I'm on R2. What should it put for the destination? It's a multicast address over here. So I need to do this map multicast. If it's a multicast on the inside, send it to 10.1. So that's what I'm doing with the multicast, and I require that to be there. Because I don't know the public addresses of the other clients, most of the time, 90% of the time, you're going to establish the control plane, my routing updates with the NHS. That's the only one that you would normally have what? The mapping for. So I do an extra map for the multicast over here towards the same address. So I have a unicast map and a multicast map towards the NHS. You understand that? So everyone will form a routing neighbor relationship with whom? With the NHS. You all good with this? And I would need to do the same command where, and let me do this as well. I'm going to run my routing protocol as well. Let's run EIGRP again. We'll talk about it. I'll show you OSPF. OSPF is not recommended to run as a routing protocol over here. And there are reasons for that. I'll explain them to you guys when we get to that point. Let's run EIGRP right now. Let's knock out most of the stuff that I need to knock out first. And then I'll show you the problems with OSPF. That's why if you go on the internet and look for most of the examples for DMVPN, you will always see EIGRP as your routing protocol. And I'll show you why. I'll set up OSPF and I'll show you the error with it or the problem with it. But let's do the good thing first. So you guys are okay with this? Everyone is mapping to what? The same NHS. Now, what about the NHS? Doesn't NHS need to respond back? So how many IP NHRP map multicast commands should I put over here? Should I say if an NHRP multicast command comes in, should I send it to 20.2, 30.3, 40.4? Again, there might be dynamic IP, so I don't have that capability. So what I used is a keyword called dynamic. Now, what does dynamic mean? All the clients over here, when they register to me, what type of mapping does it put into my NHRP table? When they registered in my NHRP table, all these guys are registered as what? Dynamic, saying what? If you want to get to 192.168.1.2, the public address is 20.2. If you want to get to 192.168.1.3, the public address is 30.3. If you want to get to 1.4, the public address is 40.4. You understand that? Everybody okay with this? But all these mappings are dynamic. Let me show you that. If you go to router 1 at this point and I do show IP NHRP over here, you'll notice all the types are what? Dynamic. So when I say IP NHRP map dynamic, I'm basically telling it, hey, listen, when you want to send an NHRP, you want to send a multicast update. So I'm going to create an EIGRP update, which has 192.168.1.1 as my source. Destination is 224.0.0.10, which is your multicast. Where do I need to send it to? It basically replicates this packet with a source of 10.1, and one by one, it goes in, searches inside where? In the NHRP table for any map that has this, and picks one at a time and sends this hello packet to 20.2 as a unicast, 30.3 as a unicast, picking it over here, 40.4 as a unicast, 50.5 as a unicast. So it's going to send 5 different packets on the outer header, although internally it's the same packet. So it converts a multicast packet into 4 or 5 unicast packets and sends it across. That's how it sets a neighbor relationship up. And it makes it very flexible and scalable because now one command will allow me to establish all my neighbor relationships. Don't forget, I do need to run routing over there. Understood, guys? So let's do that now. I'll do it on 1 first. Let's go to 2. And as soon as I do 2, it should establish what? A neighbor relationship with R1. Let's take a look. The EIGRP neighbor relationship, correct. Tunnel protocol up, and EIGRP should come up. If I go to router 1, show IP route, EIGRP, the routes are there, show IP EIGRP neighbor. I'm neighbors with him over the tunnel interface. So this is my routing table from R2. What do I do on R3? I have the config already. Boom. That's the neighbor. Up over here, this is my EIGRP. I have 2 neighbors now. And my routing, I'm building up 10.2 and 10.3, 172.16.2, 172.16.3. Let's do 4. Neighbor up. And the last one. Good so far, guys? One small thing over here, though. This is EIGRP. It is GRE. No magic. I'm done IPsec with it. I just ran routing protocols over it. It's still MGRE. So one issue that you have over here, though, is the issue with the routing protocol. EIGRP is a distance vector routing protocol which has this rule called the split horizon rule. All the routes on R1, I've gotten all the routes, but they're all received from what interface? One interface, that's the tunnel interface. Do you remember that split horizon rule, which states that if I learn a route from a particular routing or from a particular interface, I am not going to send the route back on the same interface. So at this point, although the hub, the NHS, has all the routes, it will not propagate the routes back to the other clients. Why? Because of split horizon. So it's not a GRE issue, it's more of a routing protocol issue. If I check my routes, I'll get the routes that are behind R1, which is 10.1 and 172.16.1, but I won't get the routes from 3, 4, 5. Same thing over here. Only the routes from the hub. You all good? So what do I need to do to fix it? So always remember, with EIGRP, you always need to do what? On the hub site, and only on the hub site, under the tunnel interface, no IP, split horizon, EIGRP 111. All right? So disabling what? Split horizon for EIGRP 111 under the tunnel interface. So it disables that characteristic so I can send the route back. So let's check that. I'll go and do it on R1. It will reset my neighbor relationship. I need to be under the tunnel. It'll reset all my neighbor relationships. And when I go back to router 2 now and I do the same show IP route command, guess what? I'm seeing all the other routes. So don't forget that because of EIGRP distance vector routing protocol characteristic, you will not get any routes on the spokes unless you disable that, and that's what I've done. You all good with this? All right. Now that I have my routes, now let's analyze the traffic flow. So now this was the base setup. Now let's take a look at the traffic flows. These are called phases. So DMVPN, phase 1. We'll start with phase 1. This basically takes a look at your flows. Now, in terms of control plane over here, guys, control plane meaning the route exchange. My control plane, most of the time, is going to be in a hub and spoke manner. What do I mean by that? All the other clients are establishing my EIGRP neighbor relationship only with the NHS. So it is hub and spoke in terms of what? My control plane. Okay? So this is going to be hub and spoke. What I need to take a look at is what is my data plane? And the data plane determines what phase you want to run. Do you want to run data plane in hub and spoke? Or do you want to run data plane in spoke to spoke? That will determine what phase you want to run. Good so far, guys? My control plane is what? Hub and spoke. Control plane is your routing updates. Data plane is once the routes are exchanged, how does the data flow? Now, phases basically work on the data plane. All right? Phase 1. What are the characteristics of phase 1? This is the default DMVPN phase for EIGRP as a protocol. Good so far? In this phase, what defines this phase? Data traffic is forwarded in a hub and spoke manner. So all the traffic in phase one will be in a hub and spoke manner. Okay? You don't need to do anything about it. And why is that? The reason for this is that EIGRP changes the next hop of the routes before it sends the routes, it sends the spoke routes to other spokes. Let me explain. When this guy receives a route for 2 or 3 or 4 or 5, I'm just going to say 10. I'm going to take, in my example, to save myself some writing, I'm just going to take 10.2 as an example. So on R1, in my routing table, D for EIGRP, I've learned 10.2. What's my next hop? From the tunnel, this guy. Everybody agree? Yeah? I learned it from the tunnel. How about 10.3? How about 10.4? From their appropriate spokes. That's not the issue. Once R1 receives it, R1 now needs to take that route and forward it to whom? To 3, 4, and 5. Normally in routing, A sends a route to B. B's next hop is what? A, agreed? B sends a route to C. What is C's next hop? Normal routing, B. And that's exactly what's happening over here. If you take a look at it, analyze it. A is sending the route to B. His next stop is A, which is this over here. When he sends a route to C, what is the next hop going to be? It's going to be B. So when R3 receives a route, the next hop for 10.2 is via B, R1. Because I didn't receive the route from 2, I received it from 1. So what happens is, remember I showed you that it goes direct spoke to spoke when I ping from 3 to 2? That's on the directly connected network. If I go to 3 right now, take a look. In order to get to 2, what is my next hop? 1, right? So this is what happens. This is the procedure. If I'm sitting on 3, I want to go to, I have a packet coming from 10.3, destined for 10.2. The first thing that happens is the route check. Which entry does it match? Pay attention, guys, over here. It matches. Let's choose a different color. It matches this entry, right? So what's the next stop over here? It is through the tunnel, but it's telling you the next stop is 192.168.1.1. In case when I was on the same network, it said I'm directly connected to it, so I know I need to go direct. But here it says, hey, listen, you're not directly connected. You need to go through 192.168.1.1. So when the resolution takes place, the resolution is taking place for whom? Not for this, it's via this guy. So I need to do the resolution for whom? Do I have a resolution for 192.168.1.1? Yeah, that's my hub. I don't even need to find it. I don't even need to do a request. I'll do it for that. Because my next hop is pointing towards the hub, I will do the resolution for the next hop if the route is not directly connected to me. So all my traffic from 3 to 2 will be sent from where? From the hub. Understood, guys? We'll do both. I'll do a full routing table so you guys see the difference. If I'm pinging, I'm on 3, I ping my directly connected interface 192.168.1.2. Which entry do I match in the routing table? Is this one. What does it say? You're directly connected, so I'm going to resolve directly for this IP. Just like you do with the ARP. If you're on the same network, you send the ARP request for the destination IP. What if your destination is not on your network? You do an ARP for whom? You ARP for the default gateway. So same thing over here. When I'm trying to go here, I'm going to do a resolution for what? For this guy, why it is directly connected. What if I want to ping 10.2.2.2? Which entry does it match? It matches this entry. It is not directly connected, is via somebody else. So I'm going to ARP for that or NHRP for that. NHRP for this one, I don't even need to go somewhere because I have that. I have 192.168.1.1. That is the static entry for whom? 10.1, which is my NHS. So I'm going to send this packet to NHS. And that's the default. Let's take a look at it. If I do a trace to 10.2.2.2, source 10.3.3.3, probe 1, numeric, it is going through the hub. You might say, well, it's just the resolution. No, I can keep on doing this for the rest of the night. It will always go through the hub. Why? The reason for that is it's not directly connected to me. It is via what? This guy. So my resolution is for this guy. Understood, guys? Everybody okay with this? I'm just showing it to you. You don't need to do anything about it. Why not? It's the default. But if I had done this, let me do the full table first. Now trace route to 192.168.1.2. I'm not going to 10.2. I'm going to 192.168.1.2. Probe 1 numeric. It goes to 1. That's okay because it's resolving it, but then it goes direct. And the reason for that is when I'm going to this guy, it falls under a directly connected interface. So that's why I need to go directly to it. It's directly connected. It's not via somebody. Understood? That is phase 1. Okay, let's take a look at this, Ankit, then. This is what? Phase 1. Nothing I need to do. It's default, right?